This topic is about recognizing and describing reflections in the x direction and y direction. We need to be able to write down the new equation after reflections have taken place. So let's look at the two different cases that we have. The first one is minus f of x. So let's start with sketching the graph of f of x is equal to x squared and f of x is equal to negative x squared and see what is happening. So if I sketch this out, okay, so label your axes. So f of x is equal to x squared, which means it's a parabola, U-shaped parabola going through the origin. This is f of x is equal to x squared. Now, if I wanted to draw f of x is equal to negative x squared, what I realize is that the x values are the same, so the input is still the same, but the output, all the y values will change sign. So all the output will change sign. So when all the output is positive, now all the output will be negative. So you can see clearly that this is what's going to happen. It's going to flip over and go below the x-axis. So this is f of x is equal to negative x squared. And what you can see is that this is, if I did draw it more accurately, this is a reflection of the graph of f of x along the line, along the x-axis basically. So basically in this case, what you need to realize is, oops, let's change it back. So for minus f of x, this means it's a reflection of f of x in the x-axis. Okay, so you can see that from that example. Okay, if I do a similar thing for f of negative x now, so sketch the graph of y equals x plus 1 cubed and y is equal to negative x plus 1 cubed. Now, y is equal to x plus 1 cubed, so if I were to sketch it out, okay, x plus 1 cubed has a triple root at minus 1, which means it does a twisting at minus 1. So the point of inflection is at minus 1. Okay, we can clearly find this point out, the y-intercept. Y-intercept will be when x equals 0, so 0 plus 1 all cubed, which is 1. Okay, so this is y is equal to x plus 1 all cubed. Okay, if I draw the second graph, which is y is equal to negative x plus 1 cubed, then we know that there's going to be a root at 1. So here the root is at 1. It's a negative x plus 1 cubed graph. It's a cubed graph. If you do negative x times negative x times negative x, you get negative x cubed. So that means it's going to be the other way around. So we're going to start at quadrant 2, end up in quadrant 4. So it looks something like this. Okay, I haven't drawn it very accurately, but you can see there's a reflection there. And it does go through 1, because if you substitute 0 in there, x equals 0 in there, you can get 0 plus 1 cubed, which is just 1. So it does go through 1. So this is equal to, y is equal to negative x plus 1 all cubed. So you can clearly see this is a reflection in the y-axis. Yeah. So that means f of minus x is a reflection of f of x in the y-axis. But to summarize, minus f of x means all the y values change sign, so it means reflection of f of x in the x-axis. F of negative x means the x values change signs, so it's a reflection of f of x in the y-axis. Okay, so let's go through some examples to see how this works out. F of x is equal to x cubed. Sketch f of negative x and give the new equation. So f of x is equal to x cubed. It's a cubic graph starting from quadrant 3 to 1. So if I were to draw it out, Okay, so f of x is equal to x cubed. So if I'm drawing this one out, let's call this A. So if I'm drawing this one out, it's just a cubic graph going from quadrant 3 to 1. So it looks with a point of inflection at the origin. So this is y is equal to f of x. Now it says sketch f of minus x. F of minus x is going to give the new equation. So let's do the new equation first. Is minus, replace x with minus x. So it's minus x all cubed, which is just negative x times negative x times negative x, which is negative x cubed. So f of negative x is just negative x cubed. But this is just f of negative x is just a reflection of f of x in the y-axis. So if I were to draw a line here, I'm just reflecting it along this line, so I end up getting reflection. So now it starts from quadrant 2 and ends up in 4. So this is y is equal to f of negative x. Okay, let's do the next one. So b, f of x is equal to x plus 2 all squared times x plus 1. So for what we are to sketch this one, we know we've got a double root at negative 2. So double root at negative 2, so it's going to bounce off. It's a cubic graph run by x plus 2 squared times x plus 1. And then we've got a single root at minus 1. It's a positive cubic graph, so it's going to start off at quadrant 3 and end up at 1. So it's going to look like this. It's going to bounce off minus 2 and then go through 1. This point is just 2 times 2 times 1, which is just 4. Okay, we try sketch minus f of x. So this is b we're doing. Minus f of x. Okay, minus f of x, and give the new equation, is just going to be minus x plus 2 all squared times x plus 1. And minus f of x is a reflection of f of x. Because the y value is changing, it means it's a reflection of f of x in the x-axis. So if we were to draw a line, this is your x-axis. Oops, undo. This is your x-axis, so you're reflecting it along there. So if I were to draw it in a different color, so if it's going to go through 4 here. Okay, so it's going to go like this, go like this, and bounce off there. The reflection along that. So this is y is equal to negative f of x, and this is y is equal to f of x. Let's go to the last one, which is c. Okay, see, f of x is equal to x squared minus 2x plus 1. If I factorize that, it's the same thing as x minus 1 times x minus 1, which is just x minus 1 all squared. So that means it's a quadratic, the double root at 1. Okay, so this is x, this is y. This is y is equal to f of x. So now we're trying to work out minus f of x. Minus f of x is minus x squared minus 2x plus 1, which is negative of x minus 1 all squared. Which means if I were to sketch it out, before I sketch it out, let's write what it is. So minus f of x is a reflection of f of x. Because the y values are changes, changing, so it's a reflection in the x-axis. So if I were to draw a line in the x-axis, everything's reflected along that line, so it's going to look like so. So y is equal to negative f of x. The only thing I need to label is this point here, which is obviously -1 in this case. In the other case, it would have been 1, because 0 minus 1 all squared is 1. If it's reflected, it will be -1 there. Okay. Okay, A, sketch the curve with equation y is equal to f of x, where f of x is equal to x squared minus 4. X squared minus 4 is just a quadratic, the parabola gone down by 4, so it's going to intersect, have a vertex at -4. Okay, and so something like that. And the roots of x squared minus 4 is just +2 and -2. So this is f of x is equal to x squared minus 4. Okay, for part B, so sketch the graph of y is equal to f of 4x. Okay, so B is, first is f of 4x is a horizontal stretch by scale factor 1/4, which means everything's going to be squashed by scale factor of 1/4. So that means if I sketch this out, let's make it a bit smaller because I don't have space. So instead of going through -2 and 2, it's going to be -2 times 1/4, which is -1/2 and +1/2. The y-intercept will not change, so it'll still be -4. So it'll look like this. And so y is equal to f of 4x. Okay, next one is a third y. Let's just go here. A third y is equal to f of x, means y is equal to 3 times f of x, which is a vertical stretch by scale factor 3 from the original. Okay, so if we're looking at that one, the x-intercepts won't change because it's already the y that's being affected. So it still go through -2 and 2. But the only difference is it'll go through -4 times 3 is -12. So it'll go through -12 now. So this is y is equal to 3 times f of x. Okay, next one, y is equal to f of minus x. So y is equal to f of minus x is a reflection, because the x is a changing value is reflection in the y-axis. Okay, so it's reflecting on the y-axis, which means it doesn't change, because if you look at it, it's symmetrical along the y-axis. So it's just going to be the same thing again. So we still go through -2, 2, and go through -4 here. So this is f of minus x. The last one is y is equal to negative f of x. Because the y values are changing signs, it's a reflection in the x-axis. Which means it's going to flip over, so it's going to go upside down. So if I were to label it right, it's going to go through 4 now, but then if the x-intercepts will still be the same. 2 and -2. 2 and -2. Both through 4 now. That's it. Okay, so A, sketch the curve with equation y is equal to x squared times x minus 3. So it's a cubic graph. It's got a double root at the origin. So it's got a double root at the origin, and it's got a single root at 3. It starts from quadrant 3 and gets to quadrant, oh, it's a double root. So double root means it bounces off at 0. So it bounces off at 0, it's a double root, and then it goes back to 3. Now it doesn't matter about the minimum point there, so don't worry about that. So this is what, oops, undo. This is y is equal to x squared times x minus 3. Okay, B part 1. So on the same axis, sketch the curves of the equation y is equal to 2x squared times 2x minus 3. So y is equal to 2x all squared times 2x minus 3. The same thing as replacing all the x's in the original equation by 2x. So this is just f of 2x, which is just a horizontal stretch by scale factor a half. If you've forgotten how to do this, go back to the previous lesson, transformations with stretches. Okay, which means all the roots will half. Yep. So if I were to sketch this out, so make it a bit smaller because I don't have space. So it's still going to go to the origin because half of 0 is just 0. But now it's going to go to through 3 divided by 2. 3 times a half, which is 3 over 2. So 3. Let's just sketch it out first. So it's going to look very similar. The only thing is it will go through 3 over 2 here. So this is f of 2x. Okay, next one, B part 2, is y is equal to negative x squared times x minus 3, which is the same thing as negative f of x, because all that's happened from the original equation to this is that it's multiplied by minus 1, which is a reflection. Because the y values are changing, it's a reflection in the x-axis. So you just have to reflect the original in the x-axis, which means it's going to flip over. So it's going to look like so. So the roots will still be the same, which is 0 and 3. The only difference is it's going to start off in quadrant 4, go back to 0, bounce off 0, and go that way. Okay, so this is minus f of x. So it's a reflection along the x-axis. So mirror line is at the x-axis. On the same axis, sketch the graph of y is equal to f of x, y is equal to f of minus x, and y is equal to minus f of x, where f of x is equal to x times x plus 2. Okay, so let's just draw it in one. X, y, so the original is x times x plus 2, so the roots are x equals 0 and x equals negative 2. So quadratic, so it's a positive parabola because it's a positive quadratic. This is y is equal to f of x. Let's change color, so f of minus x is a reflection. X values are changing, so it's a reflection in the y-axis. So if it's a reflection along the y-axis, this is going to be two. So this is y is equal to f of negative x. And the next one is reflection. F of y is equal to negative f of x is a reflection, because the y values are changing, it's a reflection in the x-axis with the original. So the original we're looking at, so that means this is the mirror line, reflection along the x. So that means it's going to end up looking like so. So this is y is equal to negative f of x. Should have drawn the mirror line for the other one. Let's just draw that in. So the other one was, the mirror line was here. Okay, so that's all labeled up and correct. I hope that's it. Next question. Let f of x equal x cubed. Sketch the graph of minus f of x and f of negative x separately. What do you notice? Okay, so y is equal to f of x. Let's try f of x is equal to x cubed. Is a cubic, so x, y. This is f of x is equal to x cubed. y is equal to f of x. Now minus f of x means it's a reflection. So the y values are changes, so reflection in the x-axis. Okay, so that means if I were to draw it out, so think about it in your head that its reflection is along the x-axis, so everything's going to be reflected along that. So what you end up getting is a graph that looks like this, which is going through quadrant 2 and 4. So this is y is equal to negative f of x. F of negative x is a reflection in the x-axis. Okay, so that means now for this one, I'm going to reflect. Sorry, I didn't say that right. Because the x's are changing values, it means that it's a reflection in the y-axis. Okay, so if I'm reflecting along there now if I sketch it out separately, so if I reflect along there, I end up getting this. But you can see that clearly they're both the same. So for f of x is equal to x cubed, f of negative x is the same thing as negative f of x. So we get the same graph regardless of whether we reflect along the x-axis or reflect along the y-axis. The last example I'll go through, because this is quite an easy concept, f of x is equal to half x cubed minus x squared minus 4x. It's a cubic graph looking. Sketch f of negative x and give the new equation. So let's try to sketch f of x first. So if I factorize this out, I take the half x out, then I've got x squared, take away 4x. No, that's not right. Half times what gives me minus 1, so it must be minus 2x. And then I've got half x times what gives me minus 4x, it must be negative 8. So if I factorize this out, I get half x times x minus 4 times x plus 2. So if I were to sketch f of x, it goes to the origin, it goes through negative 2, and it goes through 4. Okay, it's a positive cubic graph, so it looks like this. So this is y is equal to f of x. So if I'm trying to do f of negative x is the x values are set changing, so it's a reflection in the y-axis. So if it's the y-axis like that, so if I reflect it, that means along the y-axis, my f of minus x, this is x, this is y, so that means it's still going to go to the origin. My 4 will become negative 4 and my minus 2 will become 2. Okay, and then it's a reflection along the y-axis, so it's going to end up looking like this. Oops, it's not working, so it's going to end up looking like this way. So this is y is equal to f of negative x. As long as those intercepts are right, that's enough.